Yes students, today we will continue this exercise 7.11. So we will start from 11th sum. In this sum find the integration I limits from minus pi by 2 to plus pi by 2 function is sine square x. So we have one property in which integration of fx where limit from minus a to a given to you, then you can write down it twice of 0 to a fx dx. But this property is used if fx function is even. So here also firstly we will check function fx whether it is even or not. So if in sine square x, x is replaced by minus x, then again it gives you same value which is equals to sine square x. So f of minus x is equal to f of x. So fx is even function. So fx is even function, it can be written as 0 to pi by 2 twice of this, then sine square x and dx. So one time we have used this property. After that you can find out integration of this again by using property, means in place of x you can write down pi by 2 minus x, otherwise direct you can find out integration of this by using the formula of cos 2x. By using formula of cos 2x, sine square x it can be written as 1 minus cos 2x by 2, and after that integrate it, then upper limit minus lower limit and simplify it, it gives you value of integration. I will not completely solve it, already all of you have done up to exercise 7.10 very well. If you have done up to exercise 7.10, then very easily you can complete it. Now see question number 12. In question number 12, find the integration I in which limits from 0 to pi given to you and function is x by 1 plus sin x. Here we will use again same property from 0 to a f of dx. In this, f of x can be written as f of a minus x. By using this property, this integration I can be written as, in place of x write down a minus x, means pi minus x, divided by sine of pi minus x. All of you know that sine 180 minus theta, again it gives you sine theta, so it will be sin x. So let us suppose this is first, this is second, adding first and second, here it becomes 2i. After adding, this plus x is cancelled with minus x, you will get pi by 1 plus sin x, and pi is constant term, so you can take common outside the integration, so you will get 1 by 1 plus sin x. So how you will integrate this function 1 by 1 plus sin x? In this case, multiply and divide by 1 minus sin x. After multiplying and divide it by 1 minus sin x, function becomes 1 minus sin x divided by 1 minus sin square x, and 1 minus sin square x can be written as cos square x. Now after that, this pi remains as it is, limit remain as it is, 1 by cos square x it becomes secant square. Already all of you have done this type of integration. Now sin by cos it becomes tangent, and 1 cos when you will shift it in numerator it becomes secant. So tangent x into secant x, and all of you know that after this step integration of secant square is tangent, and integration of tangent x into secant x is secant. So after that upper limit minus lower limit, pi into tangent pi minus secant pi minus lower limit, it becomes tangent 0 plus secant 0, and when you will simplify it you will get this is equals to 2 pi, but this is value of 2i. If 2i is equals to 2 pi, then 2 is cancelled with 2 and I is equal to pi, means required integration is equal to pi. Answer will be pi in this case. So this is question number 12. Now next question 13. In 13th question, find the integration of sine raised to power 7x dx, limits from minus pi by 2 to plus pi by 2. This sum is very simple. In this case, sine raised to power 7x, this function is odd function, and all of you know that in case of odd function, integration in which limit from minus a to a given to you. If here function fx is odd function, then this is equals to 0. So by using this property, sine raised to power 7x is odd function, that's why this integration will be equal to 0. Just property is used. In one step, by using property you can simplify it. Next, question number 14. In question number 14, integration I, limit from 0 to 2 pi, function is cos raised to power 5x dx. In this case, here if you see f of a minus x means f of 2 pi minus x, this is equals to cos of 2 pi minus x, and in case of 2 pi cos remains cos, so it gives you again same function fx, means f of 2 pi minus x is equal to fx function. That's why it can be written as twice of integration from 0 to pi cos raised to power 5x. This is property. If f of 2a minus x is equal to fx, then this 0 to 2a it can be written as to twice of 0 to a. So we have used this property here. After that, how you will find out integration of this? Already this type of sum you have done. In case of odd power of cos or sine, you will separate one cos, means this cos raised to power 5 can be written as cos raised to power 4 into cos x, and cos is derivative of sine, so this cos raised to power sine you will write down it 1 minus sine square x then whole square. This cos x remains as it is, and by using substitution method you can find out the integration of this. In substitution method you will put sin x is equal to t, then it becomes 1 minus t square whole square, and this cos x into dx it becomes dt, and after that you will integrate it. So this type of integration already you have done in previous exercise. I have just explained this property. This property is used in this sum. After that, integration part you can do yourself. Next, in 15th sum, in question number 15, function is sin x minus cos x divided by 1 plus sin x into cos x. In question number 15, function is sin x minus cos x divided by 1 plus sin x into cos x, and limits from 0 to pi by 2 is given to you. In this case, by using property, this fx function can be written as f of a minus x, means in place of x write down 90 minus theta, then sine is changed into, this is value of I, this is also gives you I, sine is changed into cos, cos is changed into sine, and in the denominator also in place of cos write down sine, in place of sine write down cos. So adding these two results, I plus I, it becomes 2i, and when you will add these two, then plus sin x is cancelled with minus sin x, and cos x is also cancelled, so you will get 0 by some value, means it gives you 0, and all of you know that integration of 0 will be 0. So in this case answer is 0. This is question number 15. Now next, question number 16. In question number 16, statement is find the integration I in which function is log of 1 plus cos x and limits from 0 to pi. Again, in place of x write down a minus x, means it becomes 1 plus cos pi by pi minus x, and all of you know that cos 180 minus x, this is equals to minus of cos x, means in case of pi cos will remain cos, but in second quadrant cos is negative, so cos pi minus x, this is equals to 1 minus cos x. So now adding these two results, I plus I, it becomes 2i, then log of 1 plus cos x plus log of 1 minus cos x, and all of you know that log m plus n, it can be written as log m into n, and when you will write down these two terms in multiply, then 1 plus cos into 1 minus cos, it becomes 1 minus cos square, and 1 minus cos square can be written as sin square x. So 2i is equals to integration of log sin square x, where limits from 0 to pi, limit is pi, not pi by 4. In this sum limit is pi 0 to pi, so it becomes a log of sin square x, and all of you know that this can be written as twice of log sin x, and 2 is constant term, so taking 2 common. Now by using the property, this pi can be written as twice of pi by 2, means 2 into pi by 2. And here in this function, if in place of x you write down here 2a minus x, means log of pi minus x, then again it gives you log sin x, means f of 2a minus x is equals to fx. So this can be written as, this 2i remains as it is, this 2 remains as it is, this 0 to 2 into pi by 2, it can be written as 2 into 0 to pi by 2 log sin x. So already 1 2 is there, 2 into 2 it becomes 4. Now using the property pi by 2 minus x, this sign is changed into cos, so this can be written as log of cos x. This is value of 2i, this is also 2i, this is the value of, you can cancel this 2 with this 4 also here, if you are taking I then it becomes 2. Now if you add these two, here also cancel this, I is equal to this, here also I is equal to this. When you will add these two results, then log of sin x plus log cos x, again using the formula of log m plus log n, it can be written as log m into n. So 2i is equals to twice of 0 to pi by 2, it becomes log sin x into cos x. Now adding and subtracting